Just 1 minute, ma'am. Wait. Go, sir. You can start, sir.
Yes. Vijayalakshmi ma'am, you can proceed.
Good morning to one and all present here.
Welcome browser to have the
أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. قل أعوذ برب الناس ملك الناس إله الناس من شر الوسواس الخناس الذي يوسوس في صدور الناس من الجنة والناس. صدق الله العظيم. Thank you, ma'am.
Thank you, sir.
Yes, sir.
Happy morning to
Good
one
morning
and
to
all
one
present
and all
here.
present.
I'm Dr. J. Vijayalakshmi,
Vijayalakshmi,
Assistant Professor of
Assistant
Institute
Professor
of
of Institute of
Technology.
Information Technology.
And
Hereby to address the address from the Chief Guest. First of all, I welcome you all for the event 5 days international virtual faculty development program on exploring new frontiers in teaching tools, AI, and data analytics. I'm delighted to introduce our chief guest, Ms. P. Alamelu, Director of Engineering, IT Development, CHIPS, Bangalore, who has warmly accepted our invitation to join us today for presenting the topic on emergence of AI in logistics. Ms. T. Alamelu is an accomplished individual in the field of IT with a special focus on EW technology and data integration testing solutions. 2018, she is a volunteer teacher with eVideoloka, a non-profit organization studying classrooms for children in remote villages. She is a good worker in both team-oriented projects with adapting to new technologies. She has proficiency in all OS, including HPUX, AIX, and Solaris. She worked in almost all backend software, including DB2, Teradata, V6, etc. She has completed her education with a distinction in all levels, including the master's degree and BA degree. She has 11 years of experience in IT field working in various organizations like Polaris, Informatica, Business Solution, Process Technologies, and CTS. He had involved in various projects like leading retail chain in US, manufacturing client in US, healthcare client in US, Informatica solution for federal healthcare mandate, and software management system. We are honored to have Ms. T. Alamelu here to share their knowledge and experience with our faculty members. Today, we will talk about the emergence of AI in logistics, and I'm confident that Ms. T. Alamelu will share the valuable knowledge and opinions on this important subject. On behalf of our AIC community, I would like to welcome Ms. T. Alamelu and thank them taking the time for us today. I'm confident that this interaction with the chief guest will be a valuable learning opportunity for all of us. With that, I invite Ms. T. Alamelu to come forward and address our distinguished faculty members. Ms. T. Alamelu, we are honored to have you with us. Thank you, ma'am. We welcome you. Ma'am, can you take the show?
yeah,
Thank you, ma'am.
screen visible.
Yes, ma'am. Visible.
Good morning, everybody. Thank you for welcoming me to be a part of this FDP program conducted at MCA Institute of Technology. I personally thank Dr. Sharada, who's currently a faculty working with this institute, who has been a good friend of mine since my college years, and our friendship dating back to several years. So she has been a very studious and she is also, an intellectually inclined person, always eager to know things and always ready to teach everyone. And I hope she has taken the right path in joining this institute. And I once again thank her for providing me an opportunity to showcase my real-time knowledge in the field of logistics to the faculty of MCA Institute. And I hope the faculty would be able to use this, to implement any interesting projects with their students that could solve many of the problems that we face in the logistics domain. So thank you one and all, and I'll just begin my presentation. So I just wanted this to be an interactive session. So you are free, feel free to, stop me at any point, and you can ask me any questions in case, you're not clear with any of the terms that I'm talking about, or you have a varied opinion of the points that I'm discussing with you. Okay, so AI is something that, as experts in the field of computers, you might be aware of. But when it comes to AI in logistics, right? So what is logistics? Does anyone have an idea of what logistics is? What do you think logistics is? Anyone? Okay. So logistics is nothing but the journey of, a product or a shipment from a source to the destination. So in a larger terms, I could call this as the flow of goods from point A to the target point. So there are several steps involved in this logistics domain. The first one is the transportation. Transportation could be any medium. In earlier days, it was like, cycling to give the letters, and then came up, two-wheelers, four-wheelers, and then railways, and aviation industry came in. And now it is even this, drones that are coming to deliver your shipments. It could also happen via the sea route. So this transportation also forms a major crux of the logistics domain. And then comes the inventory. So inventory is nothing but, maintaining of the products so that whenever anyone orders the product, you're able to ship it. You don't run out of stock. We used to see, in Amazon or Flipkart, when we order a product, we used to get out of stock also for several of the products. This is because the inventory has not been maintained properly for these products. So whenever a product goes out of stock, the inventory needs to be, refilled. The stock needs to be refilled so that the products are always, at a level that is up to the market expectations. So this is a separate domain itself. And this we call it as the inventory management. And next comes the warehousing. In smaller terms, you can imagine it like our godowns, right? So warehouse is a place where you store the products. So it comes from the supplier to the warehouse and it gets stored there until an order is booked for the specific products to be shipped to the end user. The most important part in any logistics operation is the order fulfillment process. So there are fulfillment centers. You might have heard of Amazon fulfillment centers as well. So what do they do in a fulfillment center? They actually sort the products, they pick the products, they pack the products, and then they ship it. So the pick, pack, and ship or the three important steps that happens in a fulfillment center. And looking at it, it might seem to you like a very simple process, but considering the way the e-com industry has grown now, and the impact that the online shopping is making, everyone wants to be at a higher end, delivering the products that the customers demand for at the right time, and it should be of the right quality as well. So logistics is nowadays occupying more center stage, and with AI into it, we can solve n number of problems in the logistics industry. So just to give a heads up on what AI is. So AI is nothing but making the machines think like humans. So AI is not a new term. You would have learned in our early computer days about the 5th generation computers called AI, right? And it's just used to be just a one-liner of what is AI in those days when we had it in our curriculum. So way back in 1956, John McCarthy, he termed the word AI. And then from then on, there has been ups and falls in the field of AI. So there has been a fall period, which we usually call it as the AI winter, meaning there has been no activity simply because people lost interest in AI. They thought, okay, humans are better than the machines, and in no way can a machine replace the humans. So in those phases, there was a downfall in the field of AI, I would say. And then there had been an upfall also in certain phases. Like if you see from after 1964, there has been an upwards trend. And then again in 1990s, right, there was a downward trend. So the trend started moving up when IBM, had a machine called Deep Blue that was able to overpower the then world chess champion Garry Kasparov by having the machine, trained to play chess more than what a human being could do. The machine was able to beat the world chess champion. And that was, the point when people realized, okay, AI is going to definitely surpass human beings at some point of time. And then they started spending more and more on AI. More research happened after that phase, and there was never a downfall again. And in 2011, another milestone was achieved when Apple integrated a voice assistant into their iPhones. And then in 2016, we came up with the concept of machine learning and deep learning. So we are talking about ML and DL and NLP now in 2024. But if you trace back, all these has happened several years back in the history. So what is machine learning? It is training the machine based on some data patterns. And when I say deep learning, so as a human being, I know how, for example, I know how Dr. Sharda looks. I have associated her image in my brain. In my brain, the neurons are connected and interconnected so that when I see a person, I'm able to differentiate whether she is Dr. Sharda or not. Similarly, I train the machine, to process the input, and there is a several underlying hidden layers like the color of the eyes or the shape of the face, right, or the color of the hair, using which the machine can identify a pattern and then identify that person as so and so. So the neural networks comes into picture in deep learning here. And with AI or ML and DL, right? So ML and DL are naturally the subsets of AI. You have AI on the top and you have NL, DL, NLP, everything is coming beneath this. So with all these technologies in place, the internet is, surrounded or overloaded with zillions and zillions of data. Will a normal RDBMS or a SQL or a NoSQL be able to handle this? No, we certainly need a different perspective of the data. So then came in the concept of big data, which is predominantly built for storing this massive amount of data. And coming to the hardware side, we also realized that the normal CPUs are not going to work in such an infrastructure. They would definitely crash down when they see such data. And the data that the social media is pushing in is also very enormous. So then we came up with the concept of GPUs, which is the graphical processing unit, which can be used to solve any AI or ML problems. So this gives, a history of AI, how AI was perceived initially and where we are in AI now. Okay, so coming back to the challenges in the logistics industry. So in logistics, basically we classify into 3 phases, which is the first mile logistics, the middle mile or the mid mile, the last mile. So the first mile logistics is something where the product or any raw material is shipped from the supplier to the warehouse. And the last mile logistics is when the product is shipped from the warehouse to the end user. It could be an end user, or in case of, goods, right? It could be a B2B customer as. Okay. So the challenges are faced in all the phases of this logistics industry. So it could be like inaccurate demand forecasting. So never had people imagined, that they would be able to order online and, they would be able to get the product in a couple of days. And the pandemic, added, more contributing factors to this. And because of which the big stores, they faced a demand in not being able to predict the forecasting correctly. So if you don't forecast the demand correctly, you would not be filling up your inventory with the required products. And naturally, the products would run out of stock. Imagine, there is no, say, for example, some X product, right? Or an iPhone, some version, right? Imagine that product just got launched yesterday and I'm not able to order it through Amazon because the, stocks ran out, right? Now what will happen? Everyone will shift to Flipkart, right? So the Amazon sales is going to decline now. So this demand forecasting plays a crucial part in any logistics industry. And then the inventory management also needs to be done in a far better way than earlier. Because if you have a poor inventory, then you would not know when you would need to refill. And suddenly if the, product becomes so demanding, right? Nowadays, if any product is trending in the social media, then everyone wants to buy it, right? So what these online retailers do is they also look at the social media sites and they find out if any product is trending. And based on the trends, they plan to restock their inventory. So I can just think of an example, the fidget one, right? So there was this 3-cross fidget that everyone was playing around, right? In the toy industry, right? So children suddenly seemed to be fond of it, and in each house there was one fidget, right? So suddenly the demand for this shot up, and everyone was running out of stock because no one predicted that this would turn out to be a mass hit. But later on, when some analysis was done using the AI and ML algorithms, they figured out that this is being, the most searched or the most viewed product in any online shopping. Then what they do is they refill their stocks with this product so that they don't run out of stock. And real-time visibility is another challenge in the logistics domain. Say I ship a product and I want to know where my product is exactly, right? Sometimes I lose track of where it is. It might be a critical product. It might be a pharmaceutical medicine, or it might be a COVID vaccine that I'm going to ship to someone. You know how it was important in the days of pandemic, right? So lack of real-time visibility also adds a challenge in the logistics domain. So due to all these, it finally ends up in the, suboptimal customer experience, meaning the customer is not happy. I just opened up Amazon or any online shopping site and I don't find the product. Naturally, I would not be inclined to, shop using that app the next time. I would rather switch to another app where I'm being offered everything, right? So the customer experience is the key in any domain. The same is the case in the logistics. So these challenges would definitely cause an increased operational cost. And there is always a delayed risk mitigation. I'm not able to identify the risk. Say, for example, there is a Amazon sale happening, right? And I have, projected that, I'm going to sell so-and-so flat TVs at 50% off. And I did not forecast it properly, due to which, I ran out of stock, right? So had I identified this risk earlier, in the earlier phase of my project, meaning when I am about to start this sale, I need to know, like, what is the amount of, sales that is going to happen for this specific product. How do I know that? I can predict from the history of the sales data that I have with me, that how many people have, ordered this specific product in the last few months or even in the last year, and which area people has ordered the most. If I do an analysis of all those things, right, I can predict it properly. I can fill up my inventory, and it needs to be in the right warehouse. Say people from Chennai are ordering a product and my warehouse at Delhi is full with that product. What do I do with that? It will take some time for me to ship the product from Delhi to Chennai, right? So it has to be in a place near to the location where people are expecting more of that product. So all these planning will allow us, to mitigate the risks earlier. All this is possible in the logistics domain only because of AI. So we'll now move on to what are the benefits of using AI in the logistics domain. As I mentioned earlier, so the process automation is improved and I'm able to do a better predictive analysis. And I always have on-time deliveries, which in turn reduces my operational cost. And there is an improved customer experience. So using, certain chatbots or smart bots, right? People are able to know where exactly their shipment is. For example, FedEx uses a chatbot called Nina that, tells, where my shipment is. So whenever I book a shipment, say whenever I order a product on Amazon, the reason why I'm always going back to Amazon is for you guys to relate it to a real-time example. Okay. So say you order a product and once the product is shipped to me, I receive it in a box. And on top of the box, I see a label, white color sticker printed on it. I call that as the shipping label. And there is a number that is associated with that parcel, which I called as the airway bill, right? Airway bill number. And this number, once a product is, associated with this number, I will be able to track my shipment only with this number. So this number is very critical, like your, patient ID or college ID, right? You can imagine this to be a unique identifier of any shipping product. So using this AWB, if I call up Nina and ask, can you tell me where my product is, right? So Nina will be able to give me the exact location of my product. So FedEx has come up with this, smart bot, and this really helps in customer support. Otherwise, imagine the number of customer support calls any logistics operator would be, piled up with. They'll be asking for n number of shipments. What happened to my parcel? Where is my parcel? Where is my parcel struck up? Right? And the intelligent brains of human being, right, is simply involved in just, figuring out Just you hit the AWB and you find out the status of where the parcel is and you give the message back to the customer. So the human being is put here into a repetitive task of doing the same thing again and again, which is not going to add any value to this skill set. It becomes a mundane job here. Rather, if I pass this to any chatbot or a smart bot, right, it will be able to do the same job better and even more efficiently. So I can concentrate on a job which involves, higher levels of thinking. So now we come over to the use cases of AI in logistics. So as I mentioned about, the human beings only need to be employed for doing higher thinking levels, right? So we came up with this RPA, which is called the robotic process automation, wherein robots are involved to do the same jobs again and again, right? You feed the business rules into the robot, and then the robot does the same job again and again. And it always does the job with 100% accuracy, unlike human beings who over a period of time, right, may tend to deviate from accuracy levels. So how an RPA differs from AI is RPA only does the business rules again and again and produces the results. In AI, human beings are also involved on the jobs that are given by the RPA so that they can take better and informed decisions. So this is where human beings can be involved in, repeating the same jobs again and again. So I'll give you an example here. In the case of logistics, right, what usually happens is, say you are ordering a product which is of COD delivery, meaning cash on delivery, right? So when the delivery guy comes to you, he hands over the product to you and then he gets the amount from you. And what he does is, he deducts a certain commission from that amount and then the remaining amount he has to debit into the supplier's account, right? So this process, we call it as the reconciliation process. So here in specific, we call it as the COD reconciliation process. So this is just for one shipment. Imagine the number of shipments that are being done online and the number of cash on delivery that is happening in a single day. Imagine the reconciliation process, how massive it can be. And also imagine how many errors can get involved in this process. There is always a chance that, the product is being sent, but for some reason, the customer doesn't accept that product, right? He says, I don't need, and I'm forced to take back the product, right? But for some reason, if I bill this product back to the supplier, then the supplier is going to say me, hey, you didn't even sell this. How can you deduct commission from me, right? And then there has to happen some reconciliation here. So this happens back and forth between the transporter and the supplier as well. So in this case, RPA can be involved. So what they can do is, they can extract important information like the invoice number, the amount that is to be billed, right? And the address of the customer, right? And it can just prepare a summarized sheet on which a human being can act and approve, right? He need not get into the mundane task of, from the pile of invoices, he need not check out what invoice needs to be filled and so, right? So this process where a human being is also involved with a robot, we call it as a cobots. And Ernst & Young, the famous financial consultant, right? They have implemented this in a fraud detection system, and they have achieved like 97% accuracy. And there are also contracts happening in the logistics domain. Say, I am a logistics operator like, DHL or FedEx, right? I enter into contracts with the transporters I might have my own fleet as well to transport the shipments, or I might enter into contracts with any number of transporters who are, proficient in that specific domain, right? And it could be even the aviation industry, right? DHL also operates its own fleets and also enters into contracts with, the air industry segment as well. So imagine the number of contracts that needs to be established between DHL and these transporters. And imagine the amount of human personnel that has to be involved just to read all these contracts and say which class is important, which class is missing, which class I need to be, more cautious of, right? The penalties and other things I need to pay more attention, right? So here, if I employ NLP, right, it will just pick up all what is important and it will give me a summarized view so that a human legal expert can only go over, the areas where they see differences, and it will in fact be more effective when humans are involved to concentrate in what they are really skilled at, rather than going over the repetitive tasks again and again. So this cognitive contract is also an important place where AI can be used. And then comes the customs. So whenever I transport goods from one country to the other, it is the same process. Each country has a certain regulatory procedures, and they have their own set of custom forms. And also imagine the number of middlemen involved in this process and the brokerage we need to pay everyone, right? They have to go through all the customs forms submitted by the shipper and also by the end user and verify everything is correct, right? And the product to be shipped has to be in agreement with the country's regulatory policy as well. So this is not such an easy task for a human being to be employed in. So again, IBM employed Watson, which has an overall knowledge of all the legislative procedures, the regulatory documents, and even the brokerage knowledge. And so it learned easily how to automate the customs and made easy for the logistics domain as well. And one other important place where AI can help is the address management, right? So for one place, we say ST in one place, we say street in other place, right? And sometimes we give old number 5, new number 4. I mean, all these happens only in India, right? At least in the other countries, it is sort of very standardized, right? To ship in India is even a bit more challenging, right? So if you can have an address management with AI, that will definitely help the logistics domain, ship the products with ease and without having to, bear any additional cost. The reason why I'm mentioning cost here is, so imagine a product is being shipped to your location, right? The journey that it has to travel from its source to the warehouse, then from the warehouse, it is being picked up by a transporter, say FedEx or even your professional couriers, and then it is delivered to you. Say if the address is not right, instead of 44, you give a 3, right? Then the shipment has to do the same reverse journey again until it reaches the original supplier. So imagine the cost involved in this entire process, right? It will be double. So it all falls on the supplier, right? The supplier has to pay extra charges for selling his product, right? And of course, he has not even sold his product. The product is again returned back, right? For no profit, no loss, a journey has happened here. And imagine the carbon emission, imagine the environmental pollution that is happening in the shipment journey, right? If you think it is a simple problem, it seems to be very simple. But if you delve deep into it, then you understand how much journey that, that product has to take to reach at your hands. And the cost involved is highly enormous. Of course, it is also partially being borne by us, but then it is also being borne by the supplier as well. And the other use case that you might probably have been heard of is the predictive analysis, right? So this predictive analysis is a more, oft repeated, very common word now, right? So the predictive logistics, why do we use it? We use it for the capacity and the demand planning. So for example, UPS, which is the United Parcel Shipping, it's similar to, Blue Dart or FedEx in India, right? It's a parcel company in the US. So what they do is they employ AI algorithms to understand, the capacity that is required to plan their deliveries. So the capacity meaning how many fleets they require, what is the number of vehicles they require, what is the required man force they require, to transport the goods that are booked using UPS. So using this, they were able to predict close to somewhere like 70 to 80%, which really helps them to manage their business. In peak periods, right? So for example, there is a Black Friday happening in US, very much similar to our Flipkart sale or Amazon sale, the October sale that happens here, the Terra sale, right? So in those cases, even the transporters need to do predictive demand and capacity planning. Otherwise, they'll run out of fleets. Without fleets, they'll not be able to, give the product to the end user. So AI has enormously helped in predictive capacity and demand planning. Similarly, coming to the network management, right? So when I say network management, it is to anticipate the future and also to optimize the resources required for the operations in the future. For example, DHL, right? So they ship certain products using their aviation airlines also. So when you ship through Yarmo, you need to know that, only the products that are shipped, right? They need to reach the customer on time. Otherwise, no one would go for a airline move. And also the the airline needs to be filled up with, right? You cannot send a half airline. Imagine the fuel cost and the cost towards transportation, right? So you have this air freight lanes for DHL, where, they calculate the average transit time for the upcoming months, based on which they predict the delivery date for the shipment correctly. So how do I explain this is, say I want to get a laptop. I need it by next week, right? So what do? I go and then I give my PIN code, and then I see delivery date, the estimated delivery date where I can get my product, right? So if I see it only as next week, I will order here. So I'll go to another site, I'll give the same PIN code. If that guy is going to say, hey, I'll deliver you this weekend itself, I'll naturally prefer that guy, right? So how are they able to predict this estimated delivery date, right? So this is again using several AI and ML algorithms. So similarly, DHL also predicts when their shipment that are being transmitted through air would reach the customer, right? Calculating their transit time. So transit time is nothing but the time that the shipment takes from the time it is picked up till the time it reaches the end user. So this intermediate phase is called the transit time. So now we'll move on to the applications of AI in the logistics domain. So we have already seen a bit of predictive analysis, and predictive maintenance also comes in here. Using predictive maintenance, I can actually be able to predict, when my machinery is going to fail. And I can, opt for maintenance of my machinery. And then I have the route optimization, which is a very interesting, and complex puzzle. I would call it a puzzle solved using AI and ML. And this is really helping the logistics industry at a great level. And then comes the inventory management, which I mentioned already, that the inventory needs to be full based on the demands of the customers. So we'll move into each use case one by one and understand how this is being implemented in real time, so that you would be able to, relate it, right? So predictive maintenance, as I mentioned, so this is to predict the maintenance of any machinery. In the logistics domain, transport forms an important part. And for transport, machinery is very important, right? So say if you are shipping a full truck load, right? And then if the truck fails in between due to engine failure, right? Imagine the number of disasters that can happen because of this one problem, right? The end customer is not getting not getting the shipments. The shipments are delayed, due to which multiple things will be delayed, right? And then you will have to pay losses for the delay that you have created also. So in the logistics domain, each transporter gives a SLA. SLA is a service level agreement. So Blue Dot can give me an SLA saying that for products that are weighing above, say, 10 kg, I can ship from Chennai to Delhi in 2 days. Okay, this is the SLA. I'm just giving an example that is being given by Blue Dart. So what happens is, if Blue Dart doesn't meet the SLA, it is supposed to deliver the product free. So what will be Blue Dart's aim? To ship the product before 2 days, right? That will be the aim of Blue Dart or any other courier company for that matter. So all transporters have to follow this SLAs that they have committed to the customers. So if the machinery is going to fail, definitely I would not be able to meet my SLA, and I definitely cannot quote saying that, hey, my machinery failed, please excuse me and all, right? This is not going to work here. Okay, you give an SLA, you're supposed to honor it. So how do we handle this problem? Now comes the predictive maintenance. So what happens is, there are some sensors that are embedded in these machines, which will be able to find out the temperature, or it will be able to calculate the vibration, right? Say, for example, this specific part is supposed to vibrate these many times at this temperature. In case if it is not happening, right, then what will happen is, there will be alerts, and then we can go for a maintenance. This maintenance happens on demand, right? The machine is going to malfunction anytime, so we are going for a maintenance rather than the planned maintenance. I would have planned maintenance for my machine, say in the next 2 months, but even before that, this is happening. The engine is going to crash, right? Using these sensors, I can detect all these, I can predict all these, and then I can go for a maintenance. So how will this improve? This will save millions of dollars, right? Than when it is happening as an emergency repair, right? So when it is an emergency, everything costs you more, right? So this predictive maintenance help you save in terms of savings. And another main issue is, even regarding the safety. Say if the engine is malfunctioning, right, and you are supposed to travel in that airlines, right, or if your goods are supposed to, be shipped using that airlines, right? So then the safety comes into picture here, right? So, and you are also able to predict the flight delays with these sensors up to 30%, right? So 30% reduction in flight delays you are able to achieve due to this predictive maintenance. So GE Aviation has taken up this predictive maintenance to, predict the maintenance of its machinery. Not only GE, even DHL, many more top leaders in this industry, they all have this predictive maintenance into their systems, using which they are able to predict the downtime of the machinery, and they are able to plan their maintenance ahead so that nothing goes wrong. And the next interesting use case that I mentioned is the route optimization. So there is a famous problem called the traveling salesman problem. So what happens is a salesperson is being given 5 points to visit, right? Let's imagine 1, 2, 3, 4, 4 and 5, right? So which route he is going to take to visit these 5 persons depends on what route he knows and which is the cheapest or which is the shortest according to his perception, right? He might go to 1, 3 and 5 and then visit 4 and 2. Or he might start from 5, 4, 3, 1 and 2, right? He can choose whatever way he feels. But the number of routes that a human brain thinks is limited to say 4 or 5 or max 10. So for 5 routes, I can only think of 10 routes. But you won't believe me, there are 120 ways to travel. So 5 factorial ways to travel to 5 different routes. So imagine, I am a truck driver. I have been employed by UPS or Blue Dot. I need to deliver 100 parcels a day. Okay. I need to go to 100 locations. How many routes do I have? 100 factorial. Where will it lead me to? Zillions and trillions of routes of which I have no clue at all. So I would randomly pick up whichever routes I know, right? I'll try to club everything in that route and then I'll try to deliver it. And whichever I do not know, I'll go based on what my map says, right? Even before maps were there, it was even more difficult, right? I'll just ask someone and I'll go to that place. Then I'll figure out that, okay, this is the longest distance. I should have covered another point in between and then I could have come to this route, right? So if you take the 5 factorial, 120 ways, right? So how does a computer solves this problem is, so you have that 120 split into clusters of 5. So how many clusters will I be getting? 24 clusters. So I'll have 1 5 point here, 1 5 point here, 1 5 point here, and 1 5 point here. So within this 5 point, I will try to find out which is the best way to reach all these 5 points. Similarly, within this 5 points, how do I cover? Within this, how do I cover? Within this, how do I cover? Then I will try to link between these many 5 points. And then the list becomes bigger and bigger as it grows, right? So using a computer, I might not be able to give you all the, optimal ways to cover all these points. But definitely I can give you the best way to cover all these points better than any human being would do, right? So this is what UPS, a parcel company, did into their systems, which they called it Orion, which is on-road integrated optimization and navigation. So using this, what they did was they ran a POC. So they gave 100 points to a Orion driver, meaning the driver will use Orion to find out the routes and he will deliver parcels to all along those routes. And then a normal human veteran driver who has like say 20 years of experience, he knows all routes in US, he has covered these many miles. Okay, so both of them undertook the same journey at the same point from the same UPS center, right, to deliver 100 pickup points, right? So when they did this journey, right, what the team that employed them do this POC, what they figured out was the human driver, in fact, took 50 to 100 miles more than an Orion driver. So imagine more miles means more fuel, and the human driver has not even taken any rest, maybe for half an hour or so, right? Whereas the Orion employed driver, meaning the driver is using the Orion system and he is delivering the parcels. So the Orion will say, go to Tambaram first, then you go to Krompet, then you go to Palavaram, right? So it will give you the instructions. So based on that instructions, this driver is going to operate. While this driver, based on his years of experience and his knowledge, he will operate. So the outcome of this was the Orion driver performed very well than the human driver, saving some X miles. So imagine, even if one driver of UPS saves 1 mile per day, right? The entire cost calculated for a year is like more than 50 million US dollars, considering the amount of drivers that, UPS employs. This is only for one shipping company, right? Imagine this happening for all the shipping companies, all the drivers involved. The numbers could be beyond our imagination. The savings could be beyond our imagination, right? We are also doing an environmental impact here. So how is this possible using Orion? Orion has been fed up with 250 million routes in the US. And how did they feed these routes is based on expertise from the human drivers as well. And then it got trained, as it was deployed on the field. So any driver in UPS, once he, reaches the office, he'll be given, say, 50 points. And these points, the routes will always be shown by the Orion. He has to follow the route that the Orion shows. And then that resulted in these many savings for UPS. So as I mentioned, it had a considerable impact on the fuel savings. The delivery times were also greatly improved because of implementing this route optimization. So this route optimization is very interesting, and in terms of cost savings also, right? It had a deep impact in the logistics domain. So all these, it happened like in 2013 or somewhere. And by 2017, UPS was using Orion in full-fledged, right? So, and we are now in 2024. So by now, the machines would have learned over and over with a massive amount of data being fed into them. And they would now be able to perform very well better than a human driver. And also now, the real-time weather conditions, right? The real-time traffic diversions, all these also have been incorporated into the Orion system so that rerouting happens in such cases. And the driver is also able to perform more and more better. We'll now move on to the inventory management. So as I mentioned, inventory needs to be managed so that the stocks are at optimal levels. And this would definitely, be a great factor in determining the efficiency towards the cost. And Walmart or Amazon or Alibaba, be it any online retailer, what they do is, if a big sale is going to happen, they plan it much even earlier than a year. They plan it, and then they recruit the amount of workforce that needs to be involved for that specific event in advance. And then based on the past sales data, they analyze what has been the sales and what has the the inventory that needs to be maintained. What level does the inventory needs to be maintained, to provide a much better experience to the sales that is happening. So all these is possible only using AI and ML algorithms. So in case of any failure here, right, you will soon run out of stock and you will no longer be preferred by the market. And as I already mentioned, not only Walmart, all the online retailers, they also do mining of the social data, social engineering sites, and they find out what is trending, right? What is being most viewed or most searched, most liked based on the comments. And they try to stock their inventory levels based on those as well. And then comes the automated warehousing. So I already mentioned this warehousing. You can imagine it's similar to that of a godown in a smaller scale. But in a bigger scale, right, you can see this picture above, right? So this is a robot that is trying to lift this rack. Okay. So imagine the height of the rack, right? It could be very high. Okay. And so whenever the tracks are empty, right, it becomes the responsibility of the one in the warehouse to refill the stocks. So before robots, all this has been a very difficult process. Imagine for a human being, right, to lean down, pick up a product, or to bend up and pick up a product, right? Imagine the safety and precautionary measures that he has to follow in a very big warehouse like this. And again, it is a repetitive task that is not going to add any value to my intellectual capabilities, right? So why not I employ a robo here? This is what Amazon thought. And then they had the Kiva robots. These Kiva robots might be much smaller in size than this robo. The one that you see here is a CQER robots. So these robots, they lift these racks from one end to the other end, right? And then this yellow color box is called the tote. So what happens in a warehouse is all the products are piled up in the warehouse. First, you need to sort the product, right? So you say you need a shampoo, right? You need to sort all the shampoos to one place, the other products to one place. Who does all these sorting? Imagine a human sitting and doing all these, and also think of the numbers of products being sold online, right? It's not going to be possible for a human to achieve this, right? So they employed robots much in advance, might be in early, say 2010s as well, right? Kiva robots is somewhere around 2009, 2010, right? So they employed these robots to do the sorting and picking process. So they'll sort it, they'll move the racks here and there in the warehouse, and then they will pick up the product and they will place in this yellow colored boxes called totes, which is similar to the bags that you carry around, any shopping center, right? And then these totes needs to be handed over to the one at the billing counter, right? So there is preferably a human being over there who just picks up this product and he just scans it against that specific order. And then he puts it into the conveyor belt where the packing and shipping is done going forward. Okay. So now imagine the world without these robots, right? The human has to move the products and then he has to pick the products. He has to lean down several times. He has to lift his head. He has to, use n number of ladders to help him reach the product, right? And there could be some accidents happening, right? Some products might fall. There are n number of challenges in implementing this in a very, very huge warehouse. So robots came to the rescue here, and several giants like Amazon, Alibaba, even Walmart, right? They are using all these robots for doing all these operations. So the Sequoia is this robot, and this is the digit robot. This is similar to a human being, and it will just pick up the product and place it in the tot. It will go deliver the product to the person in front of the computer who has to scan it. And then the empty tots. Now, if you go to some shops, right, for getting products, any supermarkets, right, you carry the bag with you, you fill in everything, then you go give it there for billing. And that empty bags, someone at the store brings it back and place it to all these locations, right? All these is automated in a warehouse. Okay, so everything the robots do it. And you will also have to imagine the co-working space of humans and robots, right? So if the robots operate at high speeds and they clash any human being, again, there are accidents that are bound to occur. So everything has to be thought very well, experimented very well before they come into action. So these robots have designated spaces where they are allowed to move around, and human beings have some designated spaces. And they also have co-spaces where both, this robot comes and gives the package to the human being, right? So there is a co-space that is existing. So the safety has been well thought about in a warehouse. And very soon, what we hear is, in fact, a couple of them have already implemented smart warehouses where everything is automated. Okay, the human being just needs to control things, right? If he is going to say, okay, load 100 containers, that's it. He'll say load 100 containers, that's it. Then the robots will receive their jobs, like how we receive, instructions from our boss and then we act, right? The robots will receive the instructions and then they will go do all those 100 jobs and then they'll come back again and just, wait in their position for the next job to be assigned. And they also have this charging capacity also. So whenever they go out of charge or they are in need of charge, they also charge themselves. It is very interesting to, learn how all this is happening in real time. Sitting at home, we order a number of products and we, get it delivered easily at home. But the background that is happening behind this, right? It is very interesting. And if not for AI or for ML, or for RPA, which is a robotic process automation, right? All these would not have been achieved very easily. And one more important point is the labor cost. With robots in action, definitely there is a reduced labor cost. The common perception that people have is, if there are more and more, robots that are going to be deployed, right? I am going to lose my job. The biggest fear of people is losing jobs in case of AI and ML coming into existence, right? But the right technology guys take it as the low-skilled jobs are not meant for human beings. Human beings should not be deployed in doing repetitive tasks or tasks where their intelligence is not going to be involved. We will have to be involved in a higher decision level skills. So the robot does everything for you and then you decide what needs to be done. You are the master, right? So though Amazon or Walmart, they frequently cut down their labor force, right, in such warehouses. They also parallelly try to increase the jobs in the technology front, where they feel that humans would be apt to fit. The next important topic is the real-time tracking. So as I mentioned, I would always like to know where my parcel is, right? If I order, for example, a mobile, right? I will go and track it 100 times, right? When it is going to be delivered, where is it? Or if I want to go somewhere out, right? Then I find out where it is so that I can come back before the guy, reaches home, right? For planning and everything, right? So this is just for one product. Imagine the suppliers sending materials to warehouses, right? That is also an inventory supply and it involves huge volumes of products and the cost involved is also more. So they definitely need to know where the product is at the real time. So how is this possible? Using IoT sensors and using GPS. So they have sensors that can be fitted either to the product, if the product is of highly valuable, or they can fit it to the trucks that is going to carry this product. Okay, using that, they will understand where really their product is. And using GPS, you can track the location of where your product is. So DHL, just an example, DHL, but almost all logistics operators uses AI to do this real-time tracking because this is very, very critical, right? Anyone who has shipped a product definitely want to know when their product is going to reach them. So this real-time product tracking is enabled by almost all transporters. FedEx specifically uses something called SenseWare for very critical documents or, for critical pharmaceuticals. What they do is they attach a sensor. FedEx attaches a sensor to that package while shipping. Okay, and using that sensor, you can know where the product is. And also, sometimes these sensors have, temperature conditions also. For example, you are exporting a vaccine, or a medicine, right? It is important, or some perishable goods, right? You need to know if the temperature is going to rise up, right? Then you know that, okay, this product is, not going to be in a usable condition when you receive it, right? So you will have to plan it accordingly. Say if it is getting delayed, then immediately you can see once the product is arrived, what these retailers do is they'll give at 50% sale, right? Because they know it will not last long, right? So they might as well sell it at least half the rate so that they are not going for a complete loss. So this is how, the entire logistics industry is working based on the AI and ML algorithms. So I would like to take a moment here. Since I come from eShip, which is also into the logistics domain, I just want to explain you what do we do, so that it will make you understand more on the logistics use case. Because so far I have been talking about only big giants who have the required monetary funds, right? Who have the required workforce, who have the required technology. But what about the SMBs, the small and the medium-sized business, right? They do not have much money or much funding, and they definitely do not have that capacity to do all these things, right? I cannot expect professional couriers to have a sensor technology in their courier, right? Can I expect? No, right? So for such small and medium-sized business, right, eShips is nothing but a logistics intelligence platform that will help you, ship your products. So say I am for example, fast track watches, right? Or your smart watches. Fast track is one of our customers. So what they do is, fast track knows their monthly volume might be, say, like, I'm just giving a rough number here, say 10,000 shipments per month, right? What fast track does is, it will look out for all the courier companies available in the market. Okay, say FedEx, Blue Dot, Professional, whatsoever it is in the market, right? In some areas, if it is a very urban area, rural area, right? You might find something called ST couriers or G couriers or something like that, right? So it will find out what all the areas it has its customers, from where its customers are frequently booking fast track watches. And it will also find out what are all the logistics players available in that area. It will go talk to them and get a contract with them. So it will say, for example, fast track goes to Blue Dot, then says, hey, I have 10,000 shipments being shipped on a monthly basis. What is the rate that you're going to be offered? Blue Dot cannot offer the same rate as it offers for one shipment to 10,000 shipments, right? If I book through Blue Dot, say he might charge me like 100 rupees. But for fast track, since fast track is going to give you 10,000 shipments, definitely Blue Dot cannot say 100 rupees per shipment. It has to come down to some percentage. It could be even 50 or 70 rupees, right? As the case may be. Okay. So it will enter into contracts with these logistics providers, and then we will board both fast track and those logistic operators into eShips. So now fast track has onloaded, say, Blue Dot and FedEx. Okay, so now where does fast track orders comes from? Fast track has a website where you can book orders, right? Or it can happen through any of the sales channel. By sales channel, what I mean is simply the channel where you're able to sell your, could be your Shopify store or a Wix store or an Amazon store, anything. So all the orders are placed through that store. Those orders will be synced by eShips into eShips platform, right? And then for all those orders, the shipments will be created either through Blue Dot or through FedEx based on what fast track decides. And then we ship to the individual customers. Imagine if there is no platform like this for fast track, there are n number of players like eShips. We have ShipRocket, okay, and we have many other players as well. ClickPost, okay, those are all the other operators that are in the market that also provides shipping services. Okay, so imagine there are no players like this. How will Fast Track be able to manage these 10,000 shipments, right? So it doesn't know whom to, with which courier it should dispatch. And then say, for example, it is dispatching 50 through Blue Dot and 50 through FedEx. Now, what about the status of each of those shipments, right? The customer will call Fast Track and ask, may I know where the product is? When will I get the order? So what this Fast Track customer service guy has to do is, he has to log into the FedEx portal. Okay, he has to give that shipping number, and he has to find out where the parcel is. Okay, parcel is somewhere near Hosur. Then he has to tell this guy, your parcel is in Hosur. Then the another guy will call up and ask, where is my parcel? Okay, again he has to do the same process. So this is only for 1 or 2, it is okay. But imagine the volumes of shipments happening, right? And how many times will I be able to go get the tracking, put the tracking number in the specific transporter site and get the status of that shipment? Rather, if Fast Track onboards eShips, right? Whatever be the transporter, we have partners with all these logistics operators, and we will be able to give the exact location of your shipment through our portal. And one more area where we have employed AI and ML is, how does Fast Track decide whether it needs to ship through Blue Dot or ML? We call this as a courier recommendation engine, which is solely built on the principles of AI. Okay. So now, for example, Blue Dot might be serving very well from Chennai to Delhi. Blue Dot is the best carrier. Okay. But from Chennai to Bombay, FedEx is the best carrier. Okay. Maybe because in that route, the truck drivers are not operating properly, right? They take frequent breaks, because of which the shipment is getting delayed, or could be that the route is not proper, right? And because of which there is a slowness in that path. However, FedEx has employed, novel mechanisms so that it can travel faster in that route. So eShips has all these data based on the previous history, right? It will figure out who is the best shipping provider in this specific region, who has performed well, who is the top scorer. So our career performance score algorithm comes into picture here, and we are also able to rate a courier. We give ratings to the courier based on their delivery times, based on their SLAs, who is always committed to their SLAs. We rank them as the topmost. Okay. And then we recommend that logistics carrier to the business. So now Fast Track will be able to decide whom to choose between these two. And again, there is something called share of business in the logistics domain. So they will decide that 50% of the parcels needs to be shipped through Blue Dot, 20% through FedEx, and the remaining 30% needs to be done through some local courier, okay, to cut down the cost. So we also look at the past data, and then we can find out, based on the past history, how can we allocate the share of business accordingly. So all these are possible only using the emergence of AI and ML in the logistics domain. So we have the data with us, and based on the data, we are able to take some meaningful decisions that will cause an impact, to our customers. One other important feature is the expected delivery date that I mentioned much earlier, right? So, for example, some local couriers, they might not be able to give you their estimated delivery date. So what we do is, based on the past history, if a shipment has to travel from Chennai to Delhi, we might have assessed or predicted that it takes 2 days on surface mode, okay, to reach. So we will predict that 2 days and we will give it to the customer. So instead of the transporter predicting here, we as a platform are able to predict that estimated delivery date to our customers. So the customers will also get a feel of when their shipment will arrive. Rather than being not able to predict, I am here predicting an approximate date, and I will fine tune it based on the data I get in the future. And definitely I will be able to achieve 100% at some point in time. Okay, now let me move on to the challenges in implementing AI. So the data privacy concern is a very serious concern because data is available all over, and what data should be exposed, what should not be exposed, what data can be tampered and everything, right? I need to understand my data and I need to address these data privacy concerns because there are laws for the data regulations these days. I have to strictly abide by the laws when I design any framework implementing AI or ML. And the data quality and integration is also a major part because data is coming from different systems across the domains. How do I integrate those systems? And what is the quality of data that I'm receiving? In certain cases, the data might not be of any use to me, right? I can disregard those data. I no longer need the data, right? Rather, I would concentrate only on the major chunks that I'm interested in. So these are the data specific challenges. And also there is a compliance, regulatory compliance challenges because we are talking about data coming from different regions, different geographies, different countries, right? So there are regulatory compliances based on each country. And I need to take care of all those when I'm trying to consolidate and integrate and provide a solution in implementing AI. And the workforce impact, as I mentioned earlier, right? So the workforce should be trained very well in the AI technology, not only AI, the corresponding ML as well, and even deep learning, right? And they have to get trained them and be updated on the various trends that is happening in these fields and how well we can use those, to predict data from what we have. And one other constraint is the complexity of the AI models. Sometimes the AI models that I design might get too complex. It might be too biased, right? And it might not produce the right results also. So in those cases, I have to carefully consider implementation. I have to run POCs as UPS did the case of Orion, right? Similarly, I have to do several POCs and then I will have to implement AI. Moving on to the future of AI in logistics. So we have come to a point where we can think of automatic vehicles and drones, right? So recently you would have heard about, a self-driving car called Waymo, right? That is being used as a ride service like our Ola and Uber in the US. So it's a driverless car and it is being operated in Arizona and very recently in San Francisco also. So just like how we book in Ola, right? The rider books a ride through Waymo. It's a driverless car. Once he boards the taxi, right? It gets started and it has laser beams and it is being projected at 360-degree angle based on which, it is able to predict what can happen. So if there is a pedestrian here, it can predict that the pedestrian might cross anytime here, right? So, and then it changes the route like this. Or if there is a truck coming up here, right, then it diverts the route like this. I understand Waymo will have a tough time, riding in India because 50% of us are not following the rules here, right? But still, we can put into practice because never did we think we will have a Ola or Uber in India, right? So we'll be there quite soon as well with self-driving cars. And drones especially are gaining more and more traction. So you need not think it like, the drones being used only for delivering, highly critical or costly products or something like that, right? It could be a life-saving drone also. So DHL has had a drone called Parcelocopter. It's a small drone. Okay. What DHL did was, there was an area in Tanzania, which is in South Africa, right? So there was a medical center at one location, and there is a village located near an island, which is like 240 kilometers from the medical center. And there are about 400,000 people living here in this region, right? So if they need to visit the medical center, it's going to take nearly 6 hours, and the mode of transport will be through sea as well as land. So if there is an emergency, right, even in case of a blood sample, right, they need to give the blood sample, test it, and then get the result. It is definitely not going to be possible for me to, drive and then be back, right? In this case, DHL employed its drone called Parcelocopter, and it started delivering life-saving medicines in the drone. And in a matter of just 40 minutes, it was able to reach the village and then get the medical samples and then, transport it back to the medical center. And in case if any medicine is required here also, right, once they place a request in the medical center, the drone would then operate back here and deliver the medicines. So even for life-saving purposes, AI can be used. That is what I want to point out here. When it is logistics, it doesn't always be tied up with, only consumer goods. There are pharmaceutical goods, there are life-saving goods, right? Anything, right? And the next most important is the blockchain integration, which we would be, hearing on and off for a couple of years, right? The Bitcoin and the other stuff, right? So this blockchain integration enables us to perform secure transactions in a, centralized way. So the contracts that are being signed, the transactions that are happening, right? Everything is secure. And how it helps in the logistics domain is, I can easily trace back, for example, in the supply chain industry, Walmart has got some apples from a farm. Okay, now using this blockchain, I can easily trace back where this apple has come from. Okay, so that in case of any damages, right? Or in case if the apples are found to be too good, right? I can always reorder, or I can stop orders from that specific farm. This can also help in a life-saving case, like, the medicines. There are many counterfeit medicines being sold in the market, right? So Accenture and I think it is DHL again, right? Both of them did a study, and what happened was they associated an ID, right, with the pharmaceutical company, and using this ID, right, the end user who is ordering this medicine will be able to track whether it comes from a genuine manufacturer or not. So this ID will be tagged to that specific medicine. And imagine it's not just one pill that is going to go, right? In this specific box, this specific medicine, right? So the retailer might ship only a strip of that or a box of that. In any ways, right? The ID associated with it is always intact, right? It travels along with the medicine, and when the customer is ordering it, he will also be able to see the source of the medicine using this ID. So you can imagine another use cases. We have this birth certificates, death certificates, and when it comes to property, all the property, right? We are hearing of fraudulent property claims, right? If all these is integrated into this blockchain integration, right? So there will be no tampering of evidence anywhere. Okay. So that real-time example was, to help you understand how blockchain can be useful. Even diamonds, right? Lee Beers also is using this blockchain technology, wherein they are able to find out the mines from which the diamonds come from. So for the end user also will know, right, whether the mine, okay, it is coming from so and so in South Africa, and whether it is a legitimate producer of diamonds or not, or is he a fraudulent, right? So all these details can be backtracked. So there is more and more openness in the supply chain process using this blockchain integration. In the field of logistics, how this helps is you will be able to find out the source and you will be able to track its journey till it reaches the end. I have just mentioned only a couple of technologies over here, but there are quite more numbers when it comes to the future of AI in logistics, and the list is endless. So it keeps increasing day by day. Yeah. So I think I was able to give you a decent overview of how AI can be used in the field of logistics. I hope this session was useful and informative to you. I would expect or I would wish that, with the being an educational institution and the students, graduating in the field of computer science, the logistics problems can be given as a projects to these students to explore upon, so that they also increase their AI or ML skills, which is going to be in the future, a future skill, right? And they are also able to solve real-time examples in the logistics domain. Yeah, I am open for Q&A now. Thank you, everybody.
Thank you, ma'am.
Yeah.
Yes.
Any questions from participants?
Yes, participants, if you have any questions, you can ask. Yes, participants, kindly ask your doubts and clarify it. You can unmute and speak. Or you can just post your questions in the chat.
No.
You can post your questions on the chat, or you can unmute and speak. Participants, do you have any questions?
Any questions from participants?
Yes, no, you can proceed.
Very good morning to everyone present here. On behalf of MIAS Institute of Information Technology, I would like to propose vote of thanks. First of all, I thank our management for encouraging and conducting this FTP program. I also would like to thank our Honorable Secretary Janab Ilya Said Sir, Executive Committee members of MIT, Convener of MIT, Director and Assistant Director for the support and giving this wonderful opportunity. I praise my sincere gratitude to our Speaker of the Day, Ms. T. Alamelu ma'am, for making excellent presentations and engaging us throughout. Thank you, ma'am. I also thank all the professors and participants from various colleges and universities across India for taking their valuable time and ensuring their presence here. I extend heartfelt thanks to our organizing team and non-teaching staff for all the support. Thank you all.
Yes, you can fill up the feedback form. Participants, the feedback form is posted. You can fill it up soon. Yes, thank you, ma'am. Thank you so much for the wonderful session, ma'am.
Thank you, ma'am.
Thank you, everyone.
Okay, thank you, ma'am. Thank you, ma'am. Participants, kindly fill up the feedback form. So you'll be given 10 minutes. So kindly fill the feedback form. Feedback form is posted.
எனக்கு இதுல நெட் ப்ராப்ளம் வருது சார், கொஞ்சம் பாக்குறீங்களா?
Participants, kindly fill the feedback form. After filling the feedback form, you can leave the session. Even in YouTube, the feedback form is posted. You'll be given 10 minutes time
No, sir.
to fill the feedback form. Yes.
We'll
Yes,
wait
sir.
for 10 more minutes to end the meeting, sir.
Yes, of course, sir. Of
Yeah.
course. We'll wait for 10 more minutes. So after that, no extra time will be given.
பார்த்துட்டு இருக்காங்க. ப்ராப்ளம் கீழே எல்லாம் நெட்டு வரல, யாருக்குமே வரல. அதான் செக் பண்ணிட்டு இருக்கேன். நீங்க ஃபோன் பண்ணும்போது கூட நான் நியூ கால் வந்தேன். வக்கீல் சார் ஆஃபீஸ் போட்டு நம்பி பிஸ்னஸ் ரெண்டு போட முடியுமா? ஓகே, என்னன்னா நான் பவர் பண்ணிட்டு யூஸ் பண்ணிக்கிறேன். ஏன்னா நம்ம பிஸ்னஸ் அதனால வந்து பவர் பண்ணிக்கிறேன்.
Participants, feedback form and attendance list both are posted.
ரிமூவ் பண்ணிக்கிறேன்.
Sunday. Monday.
Participants, kindly fill the feedback form before you leave.
Gauss sir,
Yes, sir. Yes, sir.
I'm ending the meeting, sir.
Okay, sir. Go ahead. Go ahead. Go ahead.
Thank you,
We'll end the meeting. We will end the meetings. Thank you, participants.